Today we are reviewing solving systems of equations by graphing, and the thing that you really need to remember today is y equals mx plus b. You want to get all of your equations into the form y equals mx plus b because it's easy to graph from that form. And just to remind you, the b is where you start on the y-axis. The m is the slope, that's how you move, and it's rise over run. So, here's our first example. We need to rearrange both equations so that they look like y equals mx plus b. So the first equation, we need to subtract x on both sides. Y equals, it looks like it'd be easiest to write 4 minus x, but I really want my equation to look like y equals mx plus b, so I want to write the negative x first and then the positive 4. What is the slope here? Negative 1. 4 is where we start on the y-axis. It is the y-intercept, so you need to go up 4 from the origin and put a dot. Please notice that the y-intercept is graphed on the y-axis. I'm going to say that multiple times because there are still people who try to start at this point right here, which is so terribly wrong. Got it? Okay, got it. We haven't had any rants in this class so far today, so if you're feeling a little anger underneath things, it's totally fine. Just roll with it. Just roll with it. Once we have our y-intercept graphed on the y-axis, remember, x-axis, y-axis, got it? Now we need to use our slope. Our slope is negative 1. That means down 1, right 1, down 1, right 1. Remember that you can only use the negative once. So when you move down, you've used the negative, so then you move right. If you tried to go down and then left, you're actually using a double negative, which would be a positive, and that would be wrong. If you move up, you haven't used a negative, so then you move left to get your points. It is really helpful when you're graphing systems of equations to use a true straight edge like a ruler or the straight edge of a protractor, or since you're all supposed to have your IDs on you at all times anyway, your student ID happens to be about the right size to fit across a graph, and you can use that as your straight edge to draw in your beautiful line.
I draw pretty straight.
Next, we need to graph the other line. We need to subtract x on both sides. But notice that this is a negative y. So negative y equals negative x plus 2. Can we leave it as negative y equals negative x plus 2? Heck no. Instead, we divide everything by negative 1 or multiply everything by negative 1 or just take the opposite of every term. Y equals positive x minus 2. This one, we need to start at negative 2. On which axis? On the y-axis. Right there. What's our slope for this one? A1. So up 1, right 1, up 1, right 1, up 1, right 1, and so on, and so on, and so on.
Whoa, why didn't you just add y? Oops. Well, I know it wouldn't be negative 2.
You could add y to both sides. Then you would have x equals y plus 2. But that's not technically slope-intercept form. It has to be y equals. So then you just have to then you'd have to subtract 2 on both sides, and you'd get y equals x minus 2.
Thank you.
Okay? Good question. I like that question. That question made me happy. Okay. Now, you are not done until you have stated the solution to the system. The solution is the point where those two lines meet. So our solution is the coordinates 3, 1. All right, why don't you start this one on your own? Rearrange the first equation, rearrange the second equation, get them ready to graph. And if you're watching the video, pause the video. I mean it. Pause the video, try this on your own, and then play the video to check yourself. Okay, my class is arguing with me now. So this first one, we rearrange it. We have y equals negative x plus 3. That one's pretty easy. You start at 3 on the y-axis. That would be the vertical axis. And then a slope of negative 1. So down 1, right 1, and so on, and so on, and so on. It is helpful if you do use a straight edge and if you extend your line across the whole graph and don't have it do those weird little twitchy things like this screen does sometimes. My screen is twitchy, what can I say? Okay, now the other equation. This is where my class was getting a little upset with me because the y-intercept is positive 1/2. That means you go halfway up, and there's the y-intercept. And now from there, we have a slope of negative 1, which means you need to go down 1 whole unit to negative 0.5 and over 1 whole unit. So you just have to be kind of careful where those are going. What do you notice about this graph? They are parallel. How else can you notice that they are parallel? They both have a slope of negative 1. They have the same slope, which means that they are parallel lines. And parallel lines never ever cross. So there is no solution.
That's how it feels.
All right, next slide. How many solutions does each of the following graphs have? State whether each system is consistent or inconsistent. So here's 2 terms. Consistent. The term consistent means that there are solutions. So if there are solutions to the system, it is a consistent system. What do you suppose inconsistent then means?
No, none.
There are no solutions. So A shows 2 lines that are parallel. So there are 0 solutions and it is an inconsistent system. B, the 2 lines cross at 1 point, so there is 1 solution and it is a consistent system. C, it doesn't look like there's 2 lines graphed, but that's because the 2 lines are lying right on top of each other.
Whoa.
So there are infinitely many solutions,
But how do you know?
and that is a consistent system.
Because there has to be 2 lines.
In the book, it's going to like point at this line and give you an equation and then point at the same line and give you another equation. So there'll be 2 equations pointing at what appears to be the same line, and that will tell you that there are indeed 2. Or sometimes the book will graph it so it's like a purple or a blue or a whatever, and then they'll take like red and graph on top of it, but not cover up all of it, so you can see the purple underneath the red. Something like that. Yeah. Everyone good on number of solutions, consistent, inconsistent, and graphing lines? Okay. Here's your assignment. Notice on 11 through 14 all, there's a star next to that. For those problems, those 4 problems, state whether each system is consistent or inconsistent. So I think it's going to ask you how many solutions and also state just like we did in example 3.